All right, so today we're going to talk about parallelograms. It's a hard word to say. Parallelograms. So what we're going to do, Linus, if you remember, we looked at some rectangles and some triangles on Monday, and we kind of took them apart or decomposed them so we could find the area. And the reason we did that is so it would make them a little easier to deal with and a little more familiar to us than the shapes that we were dealing with originally. So we're going to use those strategies to look at parallelograms to find the area, and then we're also going to describe the features of a parallelogram before we get off here. So let's look at this here. Do you see any parallelograms on this slide, Linus? Make it bigger.
On that. Oops. Where did it go?
Well, it's
We lost the picture.
there we go.
Oh, there it is. There it is.
All right. All right, Linus, do you see any parallelograms on there? You can guess if you want.
Yes.
Which one is the parallelogram?
Yeah, which one do you think?
That one.
Can you say the letter?
B.
B, yeah, that's a parallelogram. Do you see any more?
Mommy, C. F. See F. Hold on, a picture of the four.
F? You think F's a parallelogram?
Hey, right. Sorry about that.
What about any others? Do you see any others?
You see any others?
Down.
You gotta say the letter.
D.
D? Well, let's look at B again. What do you notice about B? Is there anything you see about B that makes you think it's a parallelogram?
You say yes.
Yes.
What do you see there?
What do you see on B that makes it a parallelogram?
Looks like a two triangle.
A triangle.
A triangle?
Rectangle.
Rectangle.
Oh, okay.
I'm sorry about that. You like sorry.
All right, let's look at some things about those shapes. So when we look at that, we see A, B, and C are actually the parallelograms. So this one, whoop, sorry. So this one here, A, B, and C, those are our parallelograms. So what do we see? What do we see about the number of sides that a parallelogram has? Let's count the number of sides of the shape in A. Can you count those for me?
How many sides in A? How many sides in A?
Trapezoid.
How many sides?
1, 2, 3, 4.
4. That's right. So parallelograms have 4 sides. What do you see about these, like opposite sides? Like if I point to this one here, let me circle it. Maybe that'll make it easier to see. This side right here, what do you notice about it when you compare it to this side right here? Anything? What do you think?
What do you see that are alike about those?
Oh, it's like circles.
Well,
Yeah.
yes, they are circles.
That's right. What about the lines in between the circles? Do they look familiar? Do they look similar at all?
Yes.
Yeah, how? How do they look similar?
Could they be going in the same direction?
Yeah, same direction. You like that?
Yeah, they're going in the same direction. They're called they're parallel. And what that means is that if you extended those lines all the way out forever, they would never touch. That's what that means. So parallel lines never touch. If you were to draw them 1,000,000 miles long, they would never touch. So the angles, the opposite angles too. You know what the angles are?
Of a parallelogram.
Do you know what angles are?
Apples?
Yeah, we got the angles are right here.
Oh, yeah.
Kind of like the corners.
On
Okay.
the corners.
Yeah, like in your kitchen or your den or your bathroom or the corners are, those are angles. So the opposite angles are going to be the exact same.
They
Okay?
look the same.
Does those look the same to you? Those angles?
Do those look the same, Linus?
Yes.
Yeah, that's right. They're exactly the same.
Let's put it up.
So parallelograms, they have 4 sides.
It's the cover too.
The opposite sides are parallel. They're also the same length.
Okay.
And the opposite angles are exactly the same. So we're going to look at a couple. And we're going to find the area of these 2 parallelograms, okay? So we're going to use this here, and I'll show you what I'm talking about.
Area for parallelogram.
Can you see that little, it looks like a grid with colors, green and blue and yellow and red.
You see the different colors?
Can you see those? Yeah? Can you see those on the screen?
Yeah.
Okay. Well, let's look at those and see if we can find the area
That's too big.
of this right here. So what shapes do you think we can put in here inside this parallelogram that we're familiar with? How about a triangle? What do you think? You think the triangle will fit in there?
No. I
No?
think that one.
No? Does that fit?
Yeah.
Okay, let's try another one. How about we try another triangle?
Oh, yeah.
Yeah, look at there. Fits right in there, doesn't it? Now what about this space here? What about this space in the middle? What do you think we can fit in there?
Any of those look like they would fit in the middle?
Probably the blue one.
This blue one here?
Yeah.
I think you may be right. Yep, fits right in there. All right. So
Good job.
we know how to find the area of a rectangle, right? We just count the number of squares inside that rectangle. So if we want to find the area of a parallelogram, we can take the shapes that we know and find the areas of those and then add them together and we can get the area of that parallelogram. So let's do that. Let's find the area. I'm going to move all this out here. So what we're doing again, remember, Linus, that we decompose or we take apart this shape and then we rearrange and make a new shape that we're more familiar with. So I'm going to take this parallelogram apart. I'm going to take the triangle out, since we know what that is. I'm going to take the rectangle out, and then I'm going to take this other triangle out. Okay? So those 3 shapes we know fit exactly inside that parallelogram. So what about the triangles? Can we make a shape out of those that are a little easier to find the area? What do you think?
Yes.
Yeah, what shape do you think we can make?
What do you think
If I put the triangles together, how about this? What is that shape?
Sorry.
What's the entire shape? Don't even worry about the colors now. Just look at the outline. What shape is that?
Shape.
Does it look like this blue one here?
Yeah.
Watch this.
What shape is that?
It's clear.
That's a rectangle, remember?
Rectangle.
Yeah.
Oh,
So do you think we can find the area of both of these now?
sorry.
Let's count the number of squares inside the blue one. You want to? You can count with me?
Let's do it.
All right. Let's ready? Go.
Ready.
1,
1, 2,
3,
3, 4,
four,
5,
5, 6,
6,
7,
8,
8,
9, 10.
9, 10. I'll let you go.
14, 15, 16, 17, 18, 19, 20. 20.
Oh, I think you went too far.
Yeah, I went too far. Let's go. It's 18. You said 18. We'll stick with that.
18.
So if the blue one has 18, how many do you think this one has? Watch. Is it the exact same size?
Yes.
Yeah, so what's the area of this one? If this one's 18, what do you think this one is?
Rectangle.
That's right. So if the area of this rectangle is 18, what do you think the area of this rectangle is? Remember, it's exactly the same size.
Oh, yeah.
So how many squares would be in that one?
Yeah.
If you had 18 in that one, how many squares are in this one if they're the same size? How many squares?
1, 2, 3.
How many squares were in the first one?
1.
Remember last we said we had 18 squares in the blue one.
1.
Okay.
So let's count the number of squares inside this red and yellow triangle, or rectangle, excuse me. You want to count them for me?
Okay.
We got 1, 2,
1,
3,
2, 3, 4,
4.
6, 7, 8, 9, 10, 11, 12, 14, 18, 16, 17, 18,
18. We've got 18, so they're exactly the same size.
Yeah.
So what do we do now? We add those numbers together. So we've got 18 plus 18. What does that give us?
18. Mommy, 18.
18 plus 18.
18 plus 18. 是全伟的在哪里？
You have your calculator there with you?
Calculator, yeah.
So what do we have when we add 18 plus 18?
Okay. 18.
Thank you. Plus 18 equals 26.
36. That's right. So the area of this parallelogram is 36. So remember how we got that? We decomposed it, or we broke it up into different shapes that we're a little more familiar with. And then we rearranged those shapes to find the area. Okay? So let's do one more. We'll do this one here. This one looks a little different, but it's the same thing that we just did. Now, what shapes do you think will fit in here? How about I'll give you this one.
Red?
One red triangle. What's another shape of these that you think will fit in there?
Which one of those other
Yellow?
shapes do you think?
The yellow? Yeah, the yellow.
Yellow?
Which yellow? The triangle or the rectangle?
Triangle or rectangle?
With triangle.
Triangle. That's right. So what shape do you think will fit in this little bitty sliver here?
I went triangle.
Which one do you
That's
think?
Mama.
Oh, look. See, you've got a little space there.
Yeah, do you
Is there
think
another
anything will
shape
fit
here
in
that
here?
didn't have a little space?
Yes.
Which one? No, look. See? See that little space?
Do you think this big green one will fit in there? That's not
No.
going to fit, is it?
No, the green. Blue.
How about the blue? Okay, there you go. Good job. So now we're going to find the area of this parallelogram doing the same thing we just did.
Yeah.
So what do? We need to decompose this shape or break it apart, take it apart into different shapes. So let's take the rectangle, or whoop, don't do that. Okay.
This. No, punch.
Is not going to cooperate with me.
See, he's gonna take them apart again.
Well, really?
Really?
So we'll do it this way.
Trail. What the heck?
There. So sorry, I had to reset it. It wasn't cooperating. I'm sorry, Linus. But we'll remember this one was right
Yes.
here. So we're going to take it out.
Six.
This one was right here. We're going to take it out.
And
And
the
then
blue one. Blue.
This one was right in the middle, like you said, so we're going to take it out. Okay? So these shapes look exactly the same, don't they? Does this shape look exactly the same as this one?
Yeah.
Yeah. So let's rearrange it. We'll take it apart and then rearrange it so we can find the area. Watch. So what shape do we have there, Linus? This red and yellow one. What is this shape?
Rectangle.
Rectangle, that's right. Let's count the number of squares inside that one. Can you count them for me? Inside?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 12.
12.
Put it
We got 12, that's right. How about the blue one? How many are in there?
about that. 12. It's 12. You're right.
How about this little blue one here? How many squares are inside that
How
one?
many squares are in the little blue one?
Still.
How many? See, just count the little blue one.
1, 2, 3, 4, 5, 6, 7, 8.
The little blue
The
one.
little, yeah, the little blue one here.
1, 2, 3, 4.
You got to look at it as you count.
1, 2, 3, 4,
How many
5,
are in there?
6, 7, 8.
The screen is a little blurry.
Is it?
Yeah.
Okay. I'll tell you, we've got 3 in there.
I'll get ready to.
Okay, can you see 3 squares in there?
Yes, I saw it.
Okay, so we have 3 in the little blue one. We've got 12 in this one. If we add those together, what do we have?
Okay.
1,
You have your calculator there still?
12
plus
how many? 3?
3, yeah, equals 15.
15,
15.
that's right. So the area of this parallelogram would be 15.
You're right.
Okay, good job. All right, we'll go back to our PowerPoint.
Well,
And then,
There we go.
so we'll go back. We'll look at the features of this parallelogram again. Is this a parallelogram, you think, Linus?
mm-hmm.
Yeah, it is.
Yeah.
How do we know that? Because these lines, there's 4 sides. 1, 2, 3, 4. 4 sides. The opposite sides are parallel, meaning, so if we were to draw them 100 miles wide, they would never touch. And these opposite angles are the same size. So let's say that again. The features of a parallelogram, we know it's a parallelogram because there are 4 sides. The opposite sides are the same length and they're parallel, which means they'll never touch if you were to draw them 1,000,000 miles long. And the opposite angles are the same size. Okay? So that's how we know it's a parallelogram. So what I'm going to do, I'm going to post this. We're going to find the area of this parallelogram as just an exit slip. So I will post this on our Google Classroom here in a little bit as soon as the video gets done uploading. And we can work on that. You can work on that, and then we can look at it next week when we come back together.